Hey there, class. Mr. Buskey here. Hope you're having a good day so far. We're continuing with chapter 11. This chapter is kind of about, well, it's about rational expressions, okay? So in chapter 10, we worked on factoring, and rational expressions are basically just fractions with, like, expressions in them rather than numbers. So instead of, like, 1/2, it'll be, like, x minus 2 over, like, for example, we could do, like, x minus 2 over x squared plus, minus 9, something like this. That's the rational expression, okay? And so those will be very useful for Algebra 2, okay? All right, so no warm up today. Today we're talking about ratios and proportions. What are ratios and proportions is the essential question. So a proportion is a statement that states that two ratios are equal to what? Ratios are equal, okay? All right, so if we have A over B equals C over D, in the proportion A, B, C, and D are expressions in this case, not just numbers. They can be numbers. Numbers can be expressions. They're called constants, but they can also be expressions, okay? A and D in this position are called the extremes, and B and C are called the means. All right? Okay, properties of proportions. We talked about these a little while ago, but here they are. Reciprocal property. Basically, if you have A over B equals C over D, then B over A equals D over C. So you can flip them, right? So instead of 1 over 2 equals 3 over 6, we can flip them and they become what? 2 over 1 equals what? 6 over 3. Is that still true? 2 over 1 is still 2, and 6 divided by 3 is still 2, right? Yeah, so we're good. Perhaps the more important one, though, is called the cross product property. That's basically the butterfly method. I don't know if you guys have heard of that, where you cross multiply, right? So 5 times 6 equals 10 times 3. Is that true? 30 equals 30? It is, okay? Nice. All right, sounds good. Yeah, I don't really like this example down here, so we're going to skip it. We'll move down to the actual solving, so let's get into this here. Which one shall we do? Well, we have some things we want to talk about here. So before we get started here, I want you to know that, you should write this down, you can flip, proportions vertically or horizontally, but not diagonally. Okay? Yeah. So for example, we could do A over B equals C over D. We could also do A over C equals, let's see here, A over C equals B over D. Or we can do, let's see here, B over A equals D over C. So we can flip it horizontally or vertically, okay? Those are all types of things here, all right? Very cool. All right, let's do an example here. We're actually going to do, we'll do number 2 here together and see how we do, okay? So use a cross product property. So to solve any proportion, you just got to cross multiply, okay? So you have number 2 here. Negative 2 over m minus 7 equals m over 5. So we're going to cross multiply here. So let's go ahead and do that. So we have, and be careful, we have m times m minus 7 equals negative 2 times 5, right? Okay. Now how do we solve this? How do we do this? Well, we're going to distribute. Got m times m and m times 7. So we're going to get m squared minus 7m. And negative 2 times 5 is going to be what? Negative 10. All right, now we got to solve for m here, but this is going to take some factoring stuff, right? So to solve a quadratic, where we have m squared and m, we need to get it equal to what number? Equal to 0. Is it equal to 0 right now? No. How do we make it equal to 0? We're going to add 10 to both sides. So we have m squared minus 7m plus 10 equals 0. Okay? So now we're going to do some factoring. So any GCF here for on the left there? No. How many terms? There's 3. We're using our factor flowchart here, hopefully. Okay? Is it perfect square trinomial? It is not, because 10 is not a perfect square. Is it general factoring or trial and error? It's going to be general factoring because m squared is 1m squared. So we're going to do our normal diamond. We got 10 and negative 7. What numbers multiply to 10 and add to negative 7? Well, we got negative 2 and negative 5. Okay, so we're going to have m minus 2 times m minus 5 equals 0. Now how do we solve this? What do we do? Well, now we set each part equal to 0, n minus 2 equals 0, or n minus 5 equals 0. So we got plus 2, plus 5, plus 5. So we get m equals 2, or m equals 5. That's going to be our answer. All right, that was probably one of the trickier ones. We had to cross multiply by do some factoring as well. Why don't you guys try 1 and 2, see if you can figure them out, and then we'll go through them. All right, number 1, 4x over 20 equals 12 over 2. How do we solve this? We're going to cross multiply. So we have 2 times 4x, right? Equals what? 20 times 12? What's 2 times 4x? That's going to be 8x. What's 20 times 12? That's 240. Divide by 8. And x is going to equal what? 30. Awesome. All right, last example here. We have x over 3 equals 12 over x. How do we solve this? Cross multiply. We have x squared equals 36. We square root. So, in this case, we're actually going to have x equals plus or minus 6, right? It's kind of that weird thing where both 6 and negative 6 squared is going to equal 36. So it's got to be plus or minus 6. All right, sounds good. Okay, checking for extraneous solutions is kind of more of a algebra 2 thing, but we'll go ahead and do this here because it's good practice. So yeah, let's go ahead and do this. All right, so basically an extraneous solution is like a fake solution, right? It looks like if you solve it, that it's going to work out, but if you plug it back in, it's not going to work out. And you'll see what we mean here in a second, okay? So let's go ahead and do this. We're going to go ahead, we're going to solve proportion. How do we do that? We cross multiply, right? So we have 2, and write small for this problem, by the way, equals to 2 times w squared minus 16 equals, and we have w plus 4 times w minus 4. Okay, now we got to do some solving here, all right? So we're going to have to distribute. 2 times w squared is going to be 2w squared. 2 times negative 16 is going to be negative 32. And now, if you want to do the FOILing for this one, you can on the right, but this is a difference of squares. And the way this works is we want to get this to notice it's going to be a pattern. It's going to be w squared minus 16. Okay, if you were to distribute it like this, you can do that too, right? But this is a shortcut, okay? All right, now we need to get all the w squareds to one side. How do we do that? Minus w squared from both sides. So we get w squared minus 32 equals negative 16. All right. Now we need to get, now this one's kind of weird, okay? I actually would not put w squared, I would not move the 16 over, I'd probably move the 32, and you'll, okay? Sometimes if it's just w squared, I would keep, just get it alone on one side, but if you have like w squared and w, or like a quadratic and a linear term, I would like get them all alone, like get them equal to 0, okay? So we're gonna do this, you'll see why, okay? So now we have negative 16 plus 32, we have w squared equals 16, right? So how do we solve that? We square root, we get w equals plus or minus 4. Or, if you did it the other way, like I said to avoid, but you can still do this, we can do w squared, so minus 32, so another way you could do it, equals negative 16. We could also add 16 like this, and then we get w squared minus 16 equals 0, right? Well, in this case, that would be, for solving, that would be, what, w plus 4, w minus 4, difference of squares, right? Equals 0, and then you do w plus 4 equals 0, w minus 4 equals 0. It'd still be 4, negative 4, right? Okay? Now, what's an extraneous solution? So the answers are 4, negative 4, but let's show you what an extraneous solution. I'm going to check negative 4. So I'm going to plug in negative 4 into this original thing over here, okay? So we're going to do negative 4. So let's do negative 4 squared minus 16 over negative 4 plus 4 equals negative 4 minus 4 over 2. Okay? So negative 4 squared minus 16 is going to be 0 on top. On the bottom left is going to be 0, which equals negative 4 minus 4 is negative 8, and over 2. Now, are these equal things or not? They are not. So this is what we mean by a negative. This is an extraneous solution because it really is not really it's like a kind of a fake solution, right? It doesn't actually work, even though it looks like it does, okay? So that's what we mean by an extraneous solution. If you were to plug in 4, though, it would actually work, okay? All right, that's all I have for you today. Thank you for watching. Have a great day, and we will talk soon.